Hi guys, welcome back to Chemistry 24 into 7 series. In this series, we have been exploring the solution for previous year competitive exam papers. If you are new here, don't forget to subscribe and hit the bell icon for notification. In continuation of our Heck cross-coupling related problems, so today we are going to see one interesting Heck cross-coupling related problems. So let's moving into our session. So this is our problem from GATE 2025. As per this question, this substrate react with this substrate under these conditions which produce a product. So here you can find that there are four options are given. Let's solve together to find the correct option for this question. So let's write it down our question. So the first step of the reaction is these two substrates react together in the presence of potassium carbonate and acetonitrile. So once you see this condition, most of them get sense about SN2 reaction. Yes, this reaction is SN2 reaction. As per this reaction, so now you can see that this nitrogen lone pair of electron that readily attack this carbon, which kick off this bromine atom as Br minus, so which produce this intermediate. Now potassium carbonate readily abstract this proton to produce this product. So this is the first product from our first step of the reaction. Now this product react with palladium tetrakis triethylamine and DMF. So this is the reaction condition for Heck cross-coupling reaction. We have already discussed Heck cross-coupling reaction and their catalytic cycle and magnetic details and various examples. If anyone missed that video, you can find the link in the description box below. As per Heck cross-coupling reaction, the first step of the reaction is the generation of palladium zero catalysis. So here we can consider that triphenyl phosphine as L. So the initial step is the ligand dissociation happen to produce palladium zero catalysis. Since this reaction required palladium zero catalysis. So this is our product from the first step of the reaction. Now this palladium zero species readily going to insert this carbon iodine bond in this product, which produce this corresponding intermediate by oxidative addition. So now this complex readily pi complex formation with this alkene to produce this intermediate. So now the next step of the reaction is carbopalladation or migratory insertion. So here we need to figure out where our palladium going to move and similarly where our aryl part going to move. So in order to find the regioselectivity, so here we need to think about electronics of this alkene. So here you can see that this carbon attached with ester group, this slightly electron withdrawing group. So because of that ester group, this position is electron deficient. In case of this position is slightly electron rich carbon. So we know that palladium center is electrophilic center. Therefore, palladium center should move towards this carbon. In case of this aryl part going to move towards this electron deficient carbon. So which leads to generate this corresponding intermediate. So now the next step of the reaction is syn beta hydride elimination. So this is the alpha carbon, this is the beta carbon. So beta carbon has proton. However, this is not perfectly aligned with this palladium species. At the same time, this carbon-carbon bond is rotatable. So once you rotate this carbon-carbon bond, exactly our palladium species should match with this hydrogen atom. So resulting that which undergo syn beta hydride elimination to produce this respective intermediate along with the generation of this particular palladium complex intermediate, which then undergo reductive elimination to produce palladium zero catalysis regeneration. Now, this intermediate quickly undergo isomerization to produce indole product. So this is the product of our second step. This is the product from second step, which react with hydrogen gas, palladium charcoal, ethanol and acetic acid. So in general, hydrogenation by using palladium charcoal is useful for the reduction of alkenes, alkynes, and also useful for the reductive cleavage of O-benzyl as well as N-benzyl groups. So here you can see that in our product, here one N-benzyl group is present. So definitely this N-benzyl group can be cleaved under this condition. So next we should figure out either this alkene is reducible or not. In general, aromatic core not affected by palladium charcoal under hydrogenation condition. So which leads to generate this respective product. So let's moving to the our question. As per our discussion, among the four answers, the correct option for this question is option B. That's it for today's problem. I hope this video has helped you to understand this problem. If you enjoyed this session, just give it a thumbs up and share it with your friends. And don't forget to subscribe ChemOrgChem for much more content like this. And finally, thanks for watching. Bye bye.